Welcome back to my YouTube channel or the VIG Structure Hub. This is a place where you learn, build, and innovate. Today I want to tackle example number 5, and this question is from Kenya National Examination Council, Module 2. The question is on the board and it reads, figure below shows a reinforced cantilever retaining wall backfilled with granular material having unit weight of 20 kilonewton per meter cubic and an internal angle of friction phi of 30 degree. Given the coefficient of friction is 0.45 and a unit weight of reinforced concrete is 24 kilonewton per meter cubic, determine part A, pressure at the toe and the heel. So this is 7 marks. And then part B, factor of safety against overturning, that is 5 marks. And the last one, factor of safety against sliding. So this is 8 marks. This is our retaining wall. As you can see, it is made up of reinforced concrete with a density of 24 kilonewton per meter cubic. And this is the retained soil with a density of 20 kilonewton per meter cubic with an internal angle of friction, which is phi, is equal to 30 degree. So these are the dimensions. So we have 0.3, 0.4, 0.4, and 2.5 meters. On this side, you have 0.7 meters, 5.5 meters, and here is 0.5 meters. So from here to here. So let's see how we can solve such a question. So the first thing to do, I want to divide this retaining wall into different parts. So I will have the stem. So this is the stem. And I will have the base. So I will call this one the base. And here is the key. So we have 3 different parts. The stem from here to here, and then the base from here to here, and then the key from here to here. So those are the 3 different parts of that reinforced cantilever retaining wall. And then the first thing to do is to draw pressure diagram. So let's draw the pressure diagram. Soil on the wall will be on this side. So that is the pressure diagram, PA. So we call it PA. PA. Then the intensity of the pressure at the base, at this base, is given by K A times dense unit weight of soil times H. So H is the distance from here to here, and it is acting at a distance of H over 3 from the base. We also have another pressure. This is a pressure, a passive pressure. So that is a passive pressure. You call it PP, passive pressure. And the intensity of this pressure at the base is given by Kp times unit weight of soil times H2. Let's call this one as H1 and this one as H2. So this H2 is acting from here to here. So that is our pressure diagram. After pressure diagram, we now proceed to the active pressure, which is PA. So we will first calculate the active pressure PA. So PA is given by, PA is the area of this pressure diagram, which is a half base times height. The base is the intensity of pressure at the base, and then the H is this distance from here to here. Yes, like that. So in other words, it is given by W H square over 2 times sine 1 minus sine phi over 1 plus sine phi. So this is the formula. WH square over 2 times 1 minus sine phi over 1 plus sine phi, or a half base times height. Whichever you use, it will give you the same answer. So I want to use this one. And remember, this is the coefficient. 1 minus sine phi over 1 plus sine phi is the coefficient of active pressure, which is Ka. Rankine's coefficient of active pressure, which is Ka. So let's continue. Allow me to clean here. So PA is equal to, our W is the unit weight, and our H is 5.5 plus 0.45. So we have W as 20 times H. H is from here up to the top. So H is 0.45 plus 5.5, then you square over 2 times 1 minus sine 30 over 1 plus sine 30. So which imply PA, if you punch your calculator, your PA is 118 kilonewton acting at a distance of H over 3, which is 0.45 plus 5.5 over 3 from the base. Like that. So that is our PA. So after calculating our PA, the next thing to calculate is the overturning moment, because we know that the overturning moment is the moment due to horizontal force, and our horizontal force is PA. So overturning moment is equal to moment due to horizontal force. which is PA. So it's given by this formula, PA times H over 3. So overturning moment is equal to 118 times, if you add 0.45 plus 5.5, you'll get 5.95 over 3. So our overturning moment is equal to 234.03 kilonewton meter. So that is our overturning moment. We now proceed to vertical forces. So vertical forces, allow me to clean here. So vertical forces, so this one is summation of vertical forces. And as we have divided this retaining wall into 3 parts, we'll first calculate the force of this stem. So let's say stem force of stem. So the force of stem will be the area of this stem times the unit weight of concrete, which is 24 kilonewton per meter cubic. So the area is length times width. We have 5.5 from here to here. So 5.5, then times 0.4 times the density is 24. So we will have 52.8 kilonewton. So that is the force in stem. We go to force in base, or a force of base. Again, it will be the area of this base times the unit weight of the concrete. So the area of the base is length is 0.3 plus 0.4 plus 0.4 plus 2.5, which is 3.6, times the width is this distance from here to here, 0.45, then times 24. So this one will give us 38.88 kilonewton. We now proceed to the force of the key. Force of key. Again, this one will be length times width. We have 0.3 times, as you can see, from here to here is 0.7, and then from here to here is 0.45. So to get the length of the key, you will take 0.7 minus 0.45, and then you multiply by the density, which is 24. So you will get your answer as 1.8 kilonewton, like that. after calculating the force of the key, we will again calculate the force as a result of the backfill on the heel. So the force of backfill or a force due to backfill on the heel. So this one, it will be length times width. So the length is this distance from here to here, which is 2.5, and then times the distance from here to here, which is 5.5, times the unit weight of the soil, which is 20. And you will get your answer as 275 kilonewton. So that is our force due to backfill on the hill. So summation of vertical forces is equal to, you take this, add to this, add to this, and then add to this, and you will get 368.48 kilonewton. So that is the total vertical force. So let me now proceed to resisting moment, and you will allow me to clean here again. So resisting moment is the moment due to vertical forces. So moment due to vertical forces, and this one is given by the formula force times lever arm. So we'll begin by stem 1. The force in stem 1, so the force in stem 1, so stem, the force in stem is 52.8, then times the lever arm. So the lever arm is this distance, from here to the center of the stem, like that. So it is 0.3 plus 0.4 plus a half of 0.4. So this is 52 times 0.3 plus 0.4 plus 0.4 over 2. And this one is equal to 47.52 kilonewton meter. We proceed to the base. The force of the base is 38.88 times the lever arm. So the lever arm is the distance, is a half of the distance of this of the base. So it will be 0.3 plus 0.4 plus 0.4 plus 2.5, and you will get 3.6 over 2. So, and this is, and you will get 69. So it's equal to 69.98 kilonewton meter. So key, the force in key is 1.8. So key, so the force is 1.8 times the lever arm is a half of this 0.3 over 2. So this one is equal to 0.27 kilonewton meter. And then you have the backfill. Backfill, the force in the backfill is 275 times lever arm is this distance 0.3 plus 0.4 plus 0.4 plus half of 2.5 over 2. Like that. So you will get 646.25 kilonewton meter. And then the resisting moment is equal to, you will take 47.52 plus 49.98 plus 0.27 plus 646.25, and the resisting moment is 764.02 kilonewton meter. So that is the resisting moment. And then we proceed to part A of the question. Now we start solving the question. We go to part A. So you will allow me to clean here so that you can start solving part A. So part A is asking the pressure at the toe and the heel. So A, pressure at the toe and heel. So this is 7 marks. So we know that the pressure is given by this formula. So let's say this is toe and this is heel. So pressure at A, which is toe, is given by, so pressure at toe, which is A, is equal to summation of vertical forces all over B into bracket 1 plus 6 times eccentricity all over B. And you know that E is equal to B over 2 minus X. Again, if we can draw our base here, so let's draw our base here. So that is our base, and that is the center of the base, and this is the E. So this is the point where the resultant cut the base. So this is E, and this is X. And this is B over 2. Like that. So we know that X is given by moment of resistance minus overturning moment all over summation of vertical forces. So that is the formula for calculating the value of X. So which is equal to X is equal to moment of resistance is 764.02 minus overturning moment 234.03 all over 368.48. Therefore, X is equal to 1.44 meters. So E, which is equal to B over 2, so B is 3.6 over 2 minus X, which is 1.44, you will get 0.36. So that is our E. And we know that for no tension to occur, E should be within the middle third rule, which is E is less or equal to B over 6. So which imply our E is 0.36 is less or equal to our B from here to here is 3.6 over 6. It therefore imply 0.36 is less 0.6. Therefore R is within the middle third rule. So no tension. Like that. After calculating our E, we now proceed to the pressure at the toy. So pressure at the toy, which is A. So this one is given by summation of vertical forces, which is 368.48 all over B. B is 3.6. Then into 1 plus 6 times eccentricity, which is 0.36 over 3.6. Therefore, pressure P maximum, which is pressure at the toy, which is A, is equal to 163.77 kilonewton per meter square. And remember, this one should be less or equal to the bearing pressure of the ground. It therefore means our bearing pressure of the ground is 150. Let me check in the question. Yes, it's 150 kilonewton per meter square. So it means 163.77 is greater than 150 kilonewton per meter square. Therefore, not okay. Therefore, not okay. So for it to be okay, this P maximum must be less than 150 kilonewton per meter square. We now proceed to the pressure at the heel. So let's calculate pressure at the heel. Also allow me to erase. So pressure at the heel which is B. So this one is given by summation of vertical forces all over B into 1 minus 6 E over B, like that. So summation of vertical forces is equal to 368.48 all over 3.6 into 1 minus 6 times 0.36 all over 3.6, like that. So we get 40.94, which is greater than 0. So that is the minimum pressure of which is greater than 0. So it is okay. We now proceed to Roman B, or number B is the factor of safety against overturning. Against overturning. So this one is given by resisting moment all over overturning moment, and it should be greater or equal to 1.5. So our resisting moment is 764.02 all over. Our overturning moment is 234.03. So this one is equal to 3.26, which is greater than 1.5. Therefore, okay. Against overturning. We now proceed to part C, which is factor of safety against sliding. So factor of safety against sliding. So this is part C of the question. So this one is given by this formula: resisting force all over sliding force, and it should be greater than or equal to 1.55. So our resisting force is given by this formula: mu times summation of vertical forces plus passive pressure. So our passive pressure is given by W h square over 2 1 plus sine phi over 1 minus sine phi. So our passive pressure is as a result of this pressure at the toy. So this pressure, it helps in preventing this retaining wall from sliding. So this one, you can either calculate the area of this triangle or use this formula. So the answer will be the same. So it's equal to, our W is the unit weight of the soil, which is 20, times our H is from here to here, 0.7 square all over 2 into bracket 1 plus sine phi, that is 30, over 1 minus sine phi, which is 30. So this one is equal to 14.7 kilonewton. So resisting force is equal to 0.45 times total vertical force is equal to 368.48, then plus 14.7. So you will get 180.516 kilonewton. So factor of safety against sliding is equal to 180.516 all over 118. So 118 is the sliding force, which is a force as a result of the active pressure, which is PA. So the answer is 1.53. Therefore, 1.53 is less 1.55. So not okay in sliding. Not okay in sliding. So what should you do if it's not okay in sliding? So if it is not okay in sliding, you will again redesign. You can change the dimension of this key, the size of the key, and then you repeat the same process and check whether there will be sliding or not. Or you can also add a surcharge. You can add a surcharge at the top of this backfill. And again, after adding the surcharge, you will recalculate and check if there will be sliding or not. So that marks the end of that question. And if you have not subscribed to this channel, please subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. Thank you for your time, and we meet again in my next session.